Physics chapter 23, capacitance. So here we are going to talk about capacitors. So from O levels you can remember that capacitors store energy. So this is usually capacitors are really small. This is a capacitor. This is a massive capacitor that has been built in a particle accelerator in the United States. Basically what you need to understand is capacitors are used to store a small amount of energy in electrical and electronic circuits. The reason why they are needed is actually, there are many reasons why we need some small charges. For example, when they are used in computers, they can, small parts of the circuit can be functioned without making the entire system will get involved. Then if there is a power failure, there would be some parts of it will function long enough to store whatever we have been working on. So that is the use of these capacitors. So that is a very, as you can understand, it is a very valuable use. There are two leads coming from the capacitor, and they are connected to a metal plate. So to charge this or to store energy in these capacitors, these two plates, each lead is connected to a metal plate, and these plates must be given equal and opposite electric charges. Equal and opposite electric charges need to be given. There is an insulating material between these two plates, and it is called dielectric. So usually these are different kinds of capacitors, as you can see in this diagram. These are the different kinds of capacitors depending on how much of a charge is to be stored. So then to move a charge from one to move the charge onto the place of the capacitor, we have to first have a voltage supply. So there has to be a potential difference. So that energy is what comes here. Then the negative terminal of the voltage would supply or push electrons onto one plate. As a result, it is going to be negatively charged. Then from the other one, the electrons are repelled because of induced charge. As a result, it becomes positively charged. Now, when that happens, the two ammeters will give identical readings. So, if two ammeters are connected to this lead, it will be connected to it would give similar readings. So they have identical but opposite charges. When the capacitor is fully charged, what happens is the current stops the potential difference across the capacitor. There is no net flow across the capacitor is equal to the electromotive force. When the potential difference across the capacitor is equal to the EMF of the supply, then the capacitor is said to be fully charged. So what happens here is, as you can see, this is the structure of a capacitor, but usually it is coiled to get a bigger charge stored in the capacitor. So this is how it happens. So there is a delta, a positive Q, and negatively and positively charged plates are placed here. So it is given a voltage from this, as you can see. So this voltage makes the charge a possibility. So there is the electrons are moved from the negative to the a negative pole of the voltage to the negatively charged plate. Then what happens is this end becomes minus q, negatively charged. As a result, the electrons are pushed away from that, and these two would give similar readings as a result. The electrons are pushed away from here when we push electrons towards this, right? So this is actually how this is going to be charged, fully charged. So when the EMF of the supply is similar to, so this is something that you need to remember, when the EMF of the supply is similar to the, or the electromotive force is similar to the potential difference between the capacity, between the, across the plates, then we say that it is fully charged. The conventional current is the flow of positive charges. We believe that it is positive charges that move. Here we are talking about the electrons that flow. Therefore, conventional current flows in the opposite direction to the electrons. That is something that you already know. So we are just, I'm just reminding you of that. Now, if a capacitor is taken with uncharged plates, then it would have, uncharged means it would have equal amounts of positive and negative charges. So if it is now if you connect the capacitor to a supply, if electrons are pulled from plus q point and transferred it to the other, then it is going to be negatively charged, right? So that is how the supply works. It carries electrons from one end and gives it to the other. Because they have equal but opposite charges, the total charge on the capacitor is 0, right? So that is a kind of a complication that we have a problem with, because there is a positive q and a negative q. So as a result, the overall charge is going to be 0. When we say the charge stored by a capacitor, we are talking about the quantity q, which is the charge stored on each plate. We are not going to talk about the overall charge between the two plates, but the charge on one. I suppose you understand that. Now, for example, if this contains plus q charge, then this one is going to contain minus q charge. So the overall charge is 0. So we are not going to talk about that. We are going to talk about each plate. So now if you want to supply a higher charge to these capacitors, then you have to have a higher EMF connected to the leads. So then when electrons flow back around the circuit, the capacitor would be, when the electrons flow in the manner that we described earlier, then it is charged. When it flows back, then it is, we say that capacitor is discharged. So now if we take a capacitor and connect the two terminals of connect the two leads to two terminals of a battery and remove it, then and connect it to an LED in series, it will glow briefly for a moment and then it would go away, depending on how strong the capacitor is. So that is how discharging would take place. I hope you understand that. When you take a circuit, the charge that flow past a point in a given time, the charge that flow past in a given time is going to be equal to the current time graph area under. Now you take a area, you take a current against time graph. the area under that graph is going to be equal to the charge that flows past a point in that particular period of time. So that means the charge that is going to be stored on the plates of a capacitor is going to be it can be calculated or found out by using the current time graph, by drawing the current time graph and then taking the area under it. Right? So that is another factor that you need to remember. Then we talk about something called capacitance. Capacitance is the value that we obtain when we divide the charge by potential difference. Capacitance C is equal to Q upon V. So Q is going to be charge on each of the plate, right? So that is one, because both of them are equal, that equal charge is what we take. Not the sum of that or anything, but the each charge. V is the potential difference between the potential difference across the capacitor. So C equals Q upon V or Q equals Vc. That is something that we need to remember. So that's a key equation. So there are two things that the charge would depend on. The first one is capacitance, then the voltage. So if you double the voltage, charge would double, right? So now when there are not only capacitors can be charged, therefore not only capacitors would have capacitance. If you connect any object to a voltage, charge would get built up. The capacitance of that object is obtained by this equation. Capacitance is equal to charge upon voltage. So that is something that you must remember. Then capacitance is measured using farads in capital F. Now because capacitance is equal to charge upon voltage, we know that charge is measured in coulombs and voltage is in volts. So then we get 1 farad is equal to 1 coulomb per volt. 1 coulomb per volt. That is the unit of capacitance. It is measured in farad, but farads are equal to 1 coulomb per volt. Here there is a small thing that you need to remember, because here the C does not stand for capacitance. It is coulombs. But capacitance is also C. Coulombs is also C. That is something you should not confuse yourself with. Then farad is a huge quantity, huge amount of charge actually. We don't use that much of a charge. So capacities have either picofarads, nanofarads or microfarads. So pico means 10 to the power minus 12, nano means 10 to the power minus 9 farads, and micro means 10 to the power minus 6 farads. So that is another factor that you need to understand. Then capacitors are marked with their highest safe working voltage. So that means if there is excessive charge, because they are not built to withstand that kind of a charge, there would be leaking of charge across the plates. And the dielectric is no longer a dielectric. As a result, the capacitor will not function, because there is no build-up of two equal but opposite charges on either side. So if there are some capacitors, electrolytic capacitors, they have to be connected appropriately in the sense it which end needs to be connected to which the positive supply should be done properly. They cannot be fixed either way. If you connect it without knowing how to connect it, that can burn the circuit, and not only the capacitor but the entire circuit can be damaged. I hope you understood. I would If you have understood, please do question number 1 to 4. Let me give you a note on this first, and after that you can do the questions. Write down capacitors. Capacitors are devices which are used to store energy in electrical and electronic circuits. They have many functions, especially providing enough energy to an important part of a circuit to function for some time during a power failure. Pause the video and please draw this. Only that. After drawing, please write down. A capacitor is made up of two metal plates connected to two different leads, separated by an insulating material known as dielectric. Separated by an insulating material known as dielectric. When these two plates are connected to a voltage supply, the negative terminal of the supply will push electrons onto the negative plate or negative plate. Negative terminal of the supply will push electrons to the negative plate, making it negatively charged. This makes electrons to be repelled on the other plate, leaving a positive and equal charge behind. Leave a line, put a star and write down. When the potential difference across the capacitor is equal to the EMF of the supply, the capacitor is, when the potential difference across the capacitor is equal to the EMF of the supply, we say the capacitor is fully charged. I want you to draw this diagram as well, figure 23.4. I'm not going to give you a note on this conventional current. You already know that. Leave a line and write. The positive plate carries a charge of plus Q, and the negative plate carries a charge of minus Q, As a result, overall charge on the capacitor is 0. Therefore, when we talk about the charge stored by a capacitor, we talk about the charge on one plate. If a higher charge needs to be stored in a capacitor, we have to use a supply with higher EMF. However, full stop, however, capacitors would be marked the highest EMF that it can be connected to, because if excessive EMFs are used, excessive charge will lead charge to flow through the dielectric, making the capacitor to not function. Leave a line and write. In a current time graph, the magnitude of the charge stored on the plates in a capacitor is given by the area under the graph. Leave a line and write, put a star and write down. Any object can be charged by providing it with a voltage. This quality is described as capacitance. Then write down capacitance equals charge over potential difference, C equals Q upon V. So this V is you can write it down, V is the potential difference across the capacitor, Q is the magnitude of the charge on each of the capacitor's plates. So capacitance equals charge over potential difference. Then write down, the unit of capacitance is farad, capital F, and 1 farad is equal to 1 coulombs per volt. I suppose you understood how we reach that unit. Leave a line and write, because 1 farad is a large charge, large capacitance, because 1 farad is a large capacitance, we use picofarads, nanofarads and microfarads, and then write down these three. One picofarad equals 10 to the power minus 12 farads, 1 nanofarad equals 10 to the power minus 9 farads, and 1 microfarad equals 10 to the power minus 6 farads. I hope you understood. If you did understand, please do question number 1, 2, 3 and 4.